In this separations video, I'll talk about the last two types of problems, which are the evaluate type problem, in which you're given n the number of stages and the product purities and asked to find R, and the predict type problem, where you're given n the number of stages and R the reflux ratio and asked to find the product purities XD and XB. I've decided to put these two classes of problems together into one video because the solution procedure is kind of the same. Notice that in both cases, you either don't have XD or you don't have R. And if that's the case, then you cannot start by plotting the rectifying section operating line. So faced with this type of problem, your procedure must involve guess and check or a goal seek in Excel. Let's take an example that's kind of similar to the one that I did in the last video. So here, once again, F and Z are given at the same values. XD and XB are also given, but instead of the reflux ratio, what if I instead specified that n was equal to 6 stages? I feed that feed to the best stage, and my Q is equal to 0, and I'll also specify a total condenser and partial reboiler. So sometimes you'll see TC and PR are the process flow diagram abbreviations for a total condenser and a partial reboiler. So how would I go about the process then of finding R the reflux ratio? Well, as I've said above, if without R I cannot do the problem graphically because I cannot plot the rectifying section operating line. However, if I guessed a value, then I would be able to plot it. So let's draw my graph. Also forgot to say that you would need to know what alpha is, so let's just say alpha is 2. And I'm hand drawing this anyway, so it's not very precise. Just trying to show you what the algorithm would look like. I need to find R, but I don't know what R is, so I need to start with an initial guess. So this is kind of like you're working backwards, but because of the nature of the problem, you cannot just solve for R algebraically or with some algorithm. You have to guess and check. So I would start by, since I know what XD is, remember that XD is equal to 0.9 is a point that is on the rectifying section operating line. So I am going to make an initial guess for R. I don't even have to guess a number, right? I just have to sketch the line in somewhere. So this has a slope of R over R plus 1, as a rectifying section operating line should. I would also need to know what the feed operating line is. So in this case, my feed is crossing the y equals x line at Z, which is 0.4. And because my Q value is 0 for this example, that means my slope is horizontal. And right away, I know that the R that I've chosen here is not correct because it's going to intersect outside of the equilibrium curve. So I have to stay within the bottom side of the equilibrium curve. So that's a quick way to know that that reflux ratio isn't going to work. I need a different reflux ratio. So let me choose a different one. Let's choose something like that. So once again, that's just a guessed reflux ratio. I'm going to check that this is correct afterwards. This is how I would start by solving the problem, right? You always have to start by drawing a rectifying section operating line and a feed operating line, and wherever they intersect is going to be also where the stripping section operating line intersects. And I know that that has to intersect y equals x at 0.05. So right there, and connect that with a straight line gives us the SSOL. And if I was asked to find what the boil-up ratio is, the boil-up ratio is going to depend on whatever reflux ratio I have. So as R increases, this slope is going to get steeper and steeper. My boil-up ratio will also change accordingly. So now, based on this initial guess for R, I've been able to construct all 3 operating lines. And now from this point, I can start my stepping stages. So because I've specified that n is equal to 6 stages and I have a partial reboiler, that is going to equate to 7 steps. So 6 because I have 6 stages, and the partial reboiler is counting as a step because partial reboilers or condensers are in equilibrium, so they count. So my first stage is there, trying to draw my lines as straight as possible. I got a good question on email the other day about what actually where do I count these stages? And the stages are counting based on the number of times you touch the equilibrium curve, right? So these coordinates of this point is x1, y1. So the compositions that are leaving stage 1 on the vapor and liquid side respectively. That's stage 2. Stage 3 is then there. And now I put the feed in the best place. And I haven't talked about what would happen if you put the feed not in the best place. But if you do optimally locate the feed, you step over to the other operating line once it becomes advantageous to do so. So if you mentally extend this red line past this intersection point, you're going to see that you don't get as much bang for your buck out of this stage. So therefore, this is telling you that you want to make your legs as long as possible, because that means that your separation is you're getting more out of each stage then. So that's 4, 5 stages. I actually guessed pretty good. I might have guessed almost pretty good. Right? I didn't intend to guess this good. I overshot by a little bit. Right? So this is not technically the right answer. I have to land exactly on XB if I want this answer to be exactly correct. Right? But I guess pretty good. So now I would just have to go back and iterate again. I'd have to choose a reflux ratio that is a bit less. Right? And then that's going to change the slope of this curve, slope of this red line, I mean, to be sloped more like that. Maybe not that much. That's too much. But hopefully you see how the algorithm looks. Like you guess an R, you draw your operating lines, then step your stages and check and see that you get the specified number of stages. If you wanted to do this analytically, you can do this as well with Excel. I'll show you an algorithm now. So without doing Excel, I'll show you the Excel way. So use your imagination and imagine that this is in Excel right now. I'd make myself a little table. So I'd start with stages, and because I know that I have 6 stages and a partial reboiler and a total condenser, right? I know how many pieces of equipment that I have. I can start to fill in this vapor and liquid compositions now. So out of the total condenser, I know that my liquid composition has to be XD. Right, and I also know that there is no vapor composition coming out of the total condenser, so I can remove that. Right, I know that Y1 has to be in material balance with XD. Right, so Y1 would go here. Actually, it wouldn't be, well, it is material balance, right? But in this case, for a total condenser, I'm just going to sketch it out right here. My vapor, my Y1, and my XD, D, and L0, XD. My relationship between Y1 and XD for the case of a total condenser is that Y1 is equal to XD. So just in Excel, in this cell, what I would do is I would say equals whatever value is in this cell. And XD is one of the things that is given. So I could know what my Y1 is in that case. Now for liquid composition coming out of stage 1, I know what the relationship is. I could say that X1, I'm going to have to solve for this algebraically, right? The relationship is Y1 is equal to alpha X over 1 plus alpha minus 1 times X. Right, and you can rearrange this to get it in terms of X as a function of Y. So this equation that I just wrote is the same alpha equation, just rearranged for X as a function of Y. And once you know what Y1 is, then you're just using this cell to reference the value that is whatever is in Y1, and you're calculating what X1 is. Now for the next vapor composition, you're using the equation for the rectifying section operating line. You're saying Y2 is equal to R over R plus 1. So here in Excel, you'd need to have a cell that holds your value of R. Right, so this would be your initial guess or what you're going to goal seek for eventually. R over R plus 1 times X1 plus XD over R plus 1. And of course, you would code this up in Excel such that all these cells are, such that this formula is referencing other cells in the spreadsheet. And you would continue like this. X2 is equal to Y2 over alpha minus alpha Y2 minus Y2. And from there, you'd keep going. The only other difficulty comes about when you're trying to decide how do you decide where the best stage is to put the feed. So you actually have to get a little bit clever here when you want to do an analytical algorithm like this. So you need to know where this point is. So you'd have to solve for that, right? And you can solve for that by setting the equations for the two lines equal. So let me do this down here. How do we know how to know where the best stage is? The best stage, once again, is the best stage for the feed is wherever the operating lines all intersect. So because if you guess what R is, then you can solve for it, right? So you have equations for both of these operating lines. You know that y of n plus 1 is equal to R over R plus 1, xn plus 1 over R plus 1 xd. And you also know that y of n plus 1 is equal to Q over Q minus 1 xn plus, oh, it's a minus there, minus Z over Q minus 1. All right, so I can set these equal and solve for x. That gives me my x coordinate where they're going to intersect. Set equal and solve for x. Should be the only thing that I don't know, right? I know xd. If I guess a value for r, then I know what q and z are. So I need to guess a value for r, then I can solve for x. Solve for x, and this is the x of intersection. This is the x coordinate of intersection of the feed and RSOL. And once I know that, then I can get very creative with my Excel spreadsheet. And instead of just an operating line in this vapor composition, I can put a conditional statement. I can say if x, let's see, it would have to be, let me think about this. If x n minus 1, so that means if the x from the stage before, let me do it like this. This may be a little bit clearer to see. All right, the coordinates of this point are x2, y2. All right, so let me show you what the logical argument would look like for stage 3, and then this will extend all the way. So for stage 3, I would say if x2 is less than x intersection, which I found below. I found x intersection by setting the two operating lines equal to each other and solving for that xn. So if that is true, then use the equation for the RSOL. And then else, use the stripping section operating line. All right, so this is telling me that if x2, I'm solving for y3 now. Right, so this is y2, this is x2. Solving for y3, so I'm deciding how far down I want to go on this line. And my check is if x2 is less than x intersection, and in this case it's not true. x2 is greater than my x intersection, which would be there. So therefore I'd be using the rectifying section operating line. No, I had this backwards, right? This, if x2 is greater than x intersection, use rectifying section operating line. And in this case, my x2 is greater than x intersection, so I'm going to use the rectifying section operating line. Else, so if x2 is less than that, for example, on stage 4, right, my x coordinate for stage 4 would be there. And this is less than x intersection, then I'm going to use the stripping section operating line. So that would be my logical thought process there. My liquid composition would still be the same no matter what, because in all cases, my x of stage n is always having to be in equilibrium with the y of stage n, and that continues all the way down. So I'd keep doing that all the way up until I hit the partial reboiler, and when I hit the x from the partial reboiler, this is corresponding to x of b, and this is the one that must equal whatever it said in the problem statement. So this is equal to 0.05. So if everything else is logically set up, then what you can do is do a goal-seek analysis where you say, I want to set the value that is in cell where xb is equal to 0.05. by changing the cell that is in the reflux ratio. And then you can use goal-seek, and it'll solve for what R is. So that's how you'd solve that type of problem. Okay, this video is getting a little bit long. I was going to do both in the same type of video, but I think I'm going to split it up, and there'll be more videos for today, but hopefully keeping them short is going to be good for your attention span. So I got a couple more videos coming up for today.